Hello and welcome to Unit 3, Lesson 1 on net external forces. In this second example, we are going to be actually looking at the force-net equation that is going to be coming into work a lot in this unit. This force-net equation really just shows us that the net force on an object, or all the forces acting on an object that are combined, are just the sum total of all the forces that are acting on it. I put a little star on here, and I want to make it clear that, yes, direction is in fact important when we are determining the net force of an object. This will become fairly clear when we jump into this example. So moving into that, we have an object that experiences 3 external forces on it. So before we get too carried away, I'm going to just draw an object so we can start doing some free body diagramming. Right? If you want to label this thing, you can say that this is our FVD. And pretty much any force question that we're working with, I think drawing a free body diagram is going to be very, very, very beneficial to you. Okay, with that said, let's discuss the forces on here. We have a 350 Newton force down. So let's add that on here. Oops, I want to put my line tool on for this. 350 newtons down. Okay. We also have an upward force of 500 newtons. So we can label that 500 newtons. Okay. A third force is acting on this object. Well, it doesn't give us a direction for the third force. So let's just put force 3 is equal to something, because when we get to the bottom, it says if the net external force is 600 newtons, determine this third force. So this is what we're solving for. And it gives us our net external force. That's what this is going to be in the formula. And we're just going to call that Fnet. And in this case, Fnet is equal to 600 newtons. I'm going to leave a little space though, because I think some of you may see what's happening here. I haven't made direction important in this question. All right, we have this 500 newtons up, we've got this 350 newtons down, and this net force is 600 down. So I'm going to make this problem, I'm going to show off my direction here. And in the upward direction, I'm going to say we've got our upward direction is positive, so our downward direction here, I'm going to call negative. Okay. That means that this force down is negative 600 newtons. Okay, this 350 is also negative 350, but because it's showing that this is down, I'm going to keep it like a positive 350 down. And this is a positive 500 up. Okay. Let's do some solving. We have our net force formula that we're going to be working with here. So we have Fnet is equal to the sum of our 3 forces. So F1 plus F2 plus F3. Alright. Well, I think this is straightforward enough. We can just substitute values in, and then we can rearrange if we need to when we get there. I don't think it requires an upfront rearrangement. So Fnet being negative 600 newtons, plus F1, which we had 500 newtons up. That's not plus. That's equal to 500 newtons up. So we'll say positive 500. Say plus negative 350 newtons down. So I'm just going to say minus 350 newtons plus F3, which we don't know. But that's a fairly easy algebraic solve. So if we plug in here negative 600 minus 500 plus 350, we end up solving for F3. And F3 works out to be negative 750 newtons. So if we want to add direction to that, we can say that F3 is equal to 750 newtons down. Here we could have said up if we want. Okay. And I would say that is my final answer.